Have you ever heard of substances called liquid crystals? Maybe you've heard of LCDs. LCDs are found in flat-screen computer monitors, in calculators, and in cell phones. Well, LCD stands for liquid crystal display. So chances are, even if you don't know what a liquid crystal is, you have them around you all the time. So to learn a little bit more about liquid crystals, let's start by putting your hand on some of these panels that I have in front of me. So you notice that when you put your hand on some of these panels, they start changing colors. Well, what about this one on the end? Does that one change color? Do you think that it's broken? Well, over here I have a heating pad. Let's try putting this last one on top of the heating pad. When I press down, you see all the colors coming through. So it's not that this last sheet was broken, it's just that your fingers were too hot for it. So now that it's all warmed up, why don't you try using your finger to cool it down again? You see that when you run your finger across it, it turns back to black because your finger is colder than the sheet. So inside all of these sheets that I have in front of me is something called a liquid crystal. And inside this vial, I have sort of a bulk sample of what's in between all of these sheets. Now, liquid crystals can be made into different mixtures so that they can change color at different temperatures. So, what is a liquid crystal? In science class, you may have learned about the phases of matter, solids, liquids, and gases. But it turns out that there are many more phases than just these three. And liquid crystal is one of those extra phases. So, in a solid, the molecules, which are represented by these bars, are arranged in a three-dimensional lattice. So they can vibrate in place, but they can't move around. They have to stay where they are. And this is why solids keep their shape, like an ice cube. On the other hand, in liquids, the orientation of all these molecules is completely random, and the molecules can move about one another. This is why liquids take the shape of their container. Now, a liquid crystal has properties that are intermediate between the solid and the liquid. They have some order. You can see that the molecules in the liquid crystal are basically all oriented in the same direction. And this is important because they can interact with light in interesting ways, just like a solid. On the other hand, they're not fixed in place. They can move about like a liquid. So they take the shape of their container, and they're also sensitive to a lot of different things in the environment. So what can liquid crystals be used for? Well, the liquid crystals in front of me that change color with temperature can be used in these refrigerator magnets. Each number has a different mixture of liquid crystals inside of it. And when it reaches that temperature, that particular liquid crystal mixture becomes a color. And so you know what temperature it is. Another application is mood rings. The liquid crystal inside the mood ring changes color with the temperature of your skin and is supposed to tell you what mood you're in. As you've just learned, liquid crystals can be sensitive to heat. The liquid crystals that are in your cell phones and laptops are sensitive to electric fields. And here at the University of Wisconsin, Professor Nicholas Abbott is designing liquid crystals that are so sensitive that they can detect a single virus on a surface.